Okay, this is our study guide on Unit 3C, and it is designed to help prepare you for your test. There are 47 questions on this study guide. You had 26 on a quiz covering the whole part of this unit, and there will be 33 on your test. So just a little bit longer than what you had on your quiz. So now looking at these first set of problems, it goes roughly in the same order, but I will tell you to start off with that numbers 1, 2, and 6 have been moved to a later section. So I'm going to go ahead and cover them now, but the first 4 problems on your test are going to be these rational exponents. Okay, so to start off with, we have cube roots, and hopefully you know by now that that little 3 right there tells you how many times something has to appear as a factor to be able to remove it and put it outside of the radical. So we are looking for perfect cubes, and I've told you that when you have several of them, go to the smallest one, find your cubes, okay, and hopefully by looking at your chart, you know that 40 is 8 times 5. Okay, well, I don't know why it did that. Go back. All right, so 8 is a perfect cube, and the cube root of 8 is 2. So this becomes minus 2 cube roots of 5. The 5 stays underneath. It's not a perfect cube. The 8 is. It comes out, and I write the cube root of 8, which is 2. So then I'm going to go to the next one, and it doesn't really matter. I'll go back to this first one. And obviously, or most likely, if 5 goes into it, 5 is going to go into this number. And 5 goes into 135 27 times. That is a perfect cube. The cube root of 27 is 3. But there's a 2 outside here. So this is really going to be 2 times 3 cube roots of 5. And I'm about to run out of room. And then the last one I have, if I divide 320 by 5, then I will find out that it goes 64 times. Again, a perfect cube. And the cube root of 64 is 4. So this is going to be plus 4 cube roots of 5. So what I have is 6 cube roots of 5 plus 4 cube roots of 5 minus 2. 6 plus 4 is 10, minus 2 is 8. So that leaves me with 8 cube roots of 5. Okay, this is a very simplified version of the blob, y'all. The blob doesn't change. Some of y'all have been trying to combine what's underneath that, and you can't. So hopefully that won't be an issue anymore. Okay, next. These are square roots. They have a variable underneath them, but we start with the number first. And perfect square factors of 32 would be 16 times 2. 16, the square root of 16 is 4. So I'm going to have 5 times 4. And what's left underneath is the 2 and the x. Plus 98 is 49 times 2. And the square root of 49 is 7, but I have a 4 in front, so that's 4 times 7. And there's a 2 left underneath and an x, because that x has no exponent. Remember that if there's nothing there, that is a 2. Okay, so I have 20 plus 28 is 48. And what's underneath is the square root of 2x. All right, next I have 625 to the 1/4, and I have told you that you have to write some type of algebraic equivalent statement. 625 to the 1/4 is the 4th root of 625. Now, if that comes out evenly when you put it in your calculator, then fine. Put the answer to the blank and move on. If you do not know how to use your calculator, come see me. Now, 5 to the 2/3 times 5 to the 1/2. If they have the same base, then you add the exponents. The base does not change. So 5 2/3 plus 1/2 is equal to 7/6. Okay, now 7/6 is remember what's down on the bottom is that root. So that is the 6th root of 5 to the 7. And we do this, you can act like that's an x if you need to, but 6 goes into 7 one time, so that means one of those 5s come out, and I'm still at the sixth root, and there's 1 left over. Okay, if you have any trouble with any of these problems, y'all, when I'm working them, pause it, write a question down, email me, or come see me in the morning before your test. I'll be happy to help you. Okay, or during AO if that's possible. All right, next we have 27 to the 1/3 times 343 to the 1/3. So notice back here on this problem, my base was the same, so I added the exponents. Over here, the exponents are the same, so you can combine the bases. I wouldn't necessarily do that. This is the cube root of 27 times the cube root of 343. Well, if you put that in your calculator, the cube root of 27 is 3, and the cube root of 343 is 7. So this becomes 21. All right, another cube root. 54, looking at your cubes or knowing them, 54 is 2 times 27. That is a perfect cube. It comes out, so you got to pay attention to what this is, because it's telling you how many times you have to see a factor before you can pull it out. And there are 3 3's in the number 27. So this is 3 times the cube root of 2, because that's what's left underneath here. This is 8 times 2. And the cube 8 is a perfect cube. Plus sign, cube root of 8 is 2. Cube roots of 2. 3 plus 2 is 5. So that gives me 5 cube roots of 2. And we're going to pause. Be right back. So, excuse me, I'm glad there was a little pause there. So it reminded me that I wanted to tell you about, to remember about negative exponents. If I give you one of those rational ones that's going to come first, it might be something to the sort of 2, come on. All right, hold on, not working right. Give me 1 second. All right, so if I had 2 to the negative 3, to remember that that's 1 over 2 to the third, which is 1 over 8. So keep in mind, some people have gotten confused. The 1 over a number is only happening when you have a negative exponent. So keep in mind, because you will be expected to know that on your test. Okay? All right, so continuing on with number 7. We have find all the real square roots. Now what you have to pay attention to is this word right here. And square is, of course, a 2. We're talking about a root of 2. And so that's an even number. And that means that if any of these is negative, like this one over here, you need to write not a real number. Do not write no solution. I'm not asking you to solve something. Okay? That's the answer you should put, not a real number. Okay? 25 over 169. The square root of 25 is 5. The square root of 169 is 13. Now, if this is an even number, then you have 2 possibilities. This is the only type of problem that you will have plus or minus. There's no radical in the original problem. So if there's no radical and it's an even number, then you need to remember the plus or minus. And this one, plus or minus, use your calculator if you don't know, if you get confused in any way with those decimals. Okay? All right. Next, we have 5, find all the real cube roots. And this is, of course, odd. Cube is referring to the third root of something. And it is an odd number, and therefore you will always have an answer. So if the original problem is negative, then your answer is negative. The cube root of 125 is 5. The cube root of 512 is 8. The cube root of 64, it's negative. Your answer will be negative. Cube root of 64 is 4. The cube root of 27 is 3. Okay, so never ever have not a real number for these kinds of problems. Okay, now we have find the real number roots. Okay, we will not have plus or minus. There is a radical in the answer. Okay, but we do have to pay attention to, what do we got here? Okay, so we do have to pay attention to what the root is that's being asked of us. Okay, 6th root of 64 is 2. Okay, you need to do that on your calculator if you don't know how to do it on your calculator. And that's another thing as we go through here. I didn't talk about that back up here, but in problems number number 1, number 4, number 6. Okay, if you put it in your calculator and it gives you a radical or it gives you a decimal, then you must show some kind of work on your paper supporting your answer. Okay, if you put it in your calculator and it gives you a whole number, then fine. These problems I did ask for algebraic equivalence. Okay, after that, you may just put in the 6th root of 64. I'm fine with that. Okay, let's go to the 5th root of negative 243 over 3,125. On your calculator, depending on what kind you have, first of all, if there's a negative, it's an odd, so that's negative. Then I'm going to take the 5th root of 243, which is 3, and the 5th root of 3125, which is 5. So that answer is negative 3/5. Okay, when we get to the next one here, let's go here. We got the 4th root of a negative number. Can't take the 4th root of a negative number, so this is not a real number. Okay. Next, the negative is on the outside. It is not on the inside like we had on number 11, so that means my answer is negative, and the 4th root of 256 is 4. So just pay attention to those little details and we won't have any trouble. Okay, next. The directions will go in the same order on the test as they are on the study guide. Like I said, except for those first 2 problems, I moved them so that it would be around more other problems of a similar nature. Okay, simplify each radical expression. If you put the square root of 81 in your calculator, you get a whole number, no problem. We put a 9. There's a 2 here, and 2 goes into 12 evenly. It goes in 6 times, and if it goes in evenly, or however many times it goes in, it comes out from under the radical. There's nothing left over, so I am done with that problem. Okay? And then I have the 4th root of 256. Again, if you put that in your calculator, you get 4. So we don't have to worry about showing how we got that. 4 goes into 36 9 times, so that's x to the 9th. 4 goes into 7 1 time. All right, it's the 4th root. And how many are left over after 1 time? There are 3 left over. Okay, a couple of things about this. Number 1, it came out odd. And I look over here, and it is even to start with and even underneath, and it came out odd. So I need absolute values around the x. The y starts off even, but here it is not even. So even though it came out odd, I don't need absolute value. So the rule that we use here is we remember even, even, odd. Okay. The other thing that people need to be aware of is this particular part of the problem, however you want to write it. Some people are writing it like this, and this is not the same thing as that right there. All right, that 4 needs to be smaller, and it needs to be in between the crook of your radical and the straight part. And if it's not, then it has a different meaning. So please be careful when you are writing your answers. All right. The cube root of 81. Okay. The cube root of 81, if you put that in your calculator, you don't get a whole number. Therefore, you must show me some work and break this down. So the largest cube factor of 81 is 27. So I know that 81 is 27 times 3. That is a perfect cube. That means it's going to come out. So I'm going to write a 3, because that's the cube root of it. 3 goes into 6 2 times, so that's a squared. 3 goes into 10 3 times, and it has 1 left over. So this is a perfect square, but this is not. So what I'm left with is, let me try to write that a little bit smaller so it'll fit in my answer blank here. 3a squared b cubed, and then I have a cube root. And what I have left underneath here is a 3 and a b. Now, if we need to check that, okay? 3 goes into 6 2 times, so we're clear. 3 goes into 10 3 times with 1 left over, so that's why there's 1 here. 27, the cube root of 27, the 3 is on the outside. This 3 is left on the inside. Okay, and remember, y'all, if you have any questions, please email me about it. I can explain things different ways if that's what you need. Okay, whatever I can do to help you get things correct. All right. So again, the third root of 108 is not going to come out evenly on your calculator, so you got to break it up. Find that perfect cube, which in this case again is 27, because 27 times 4 is 108. Okay, 27 is 3 to the third power. It is 3 times 3 times 3. I have to see 3 of the same thing to be able to bring one out. So I'm going to have a 3. 3 goes into 4 one time. 3 goes into 9 3 times. And so what do I have left? I'm going to still have this 3 here for my index. I have a 4. I have an X, and I don't think I have any Y's. So again, I'm going to check it. This is not an even number, so I don't have to worry about absolute value. Okay, but again, 108, 27 times 4, cube root of 27 is 3. The 4 stays underneath. 3 goes into 4 one time, so this is once with 1 left over. And 3 goes into 9 3 times. And don't forget your index. All right, moving along. Number 17, square root. Okay, so that's one thing people just got to pay attention to when I'm asking for square roots and when I'm asking for cube roots or fourth roots or whatever. Square roots, the largest square root of factor of 54 is 9. It's 9 times 6. So I'm going to bring out a 3. Again, that's the 2 there. 2 goes into 3 one time with 1 left over. So it'll stay underneath. 2 goes into 5 twice. And so what do I have left? I have a 6 underneath. 2 went into 3 one time with 1 left over. And 2 went into 5 two times with 1 left over. So we have 3x squared times the square root of 6xy. All right. So the next one. The fifth root of negative 64. Okay, a negative with an odd always means our answer is going to be negative. All right, so that's clears that up, and you don't have to worry about it the rest of the problem. 64 is 4 to the 6th, I believe. So it's 4 to the 6th, or 32 times 2. Look at those fifth powers, however you wish to do it. 32 is a perfect fifth, okay? It is 2 to the 5th. So the fifth root of 32 is 2. 5 goes into 14 twice. Yes, I'm going to have some left over. 5 goes into 20 4 times. And now I'm going to have a fifth root. I have a 2 left right here. It did not get taken out. So there's my 2. 5 went into 14 2 times with 4 left over. And I hope I don't have any y's because I don't have any room. So negative 2x squared y to the 4th times the fifth root of 2x to the 4th. Is that right? 2. Yeah, 5 goes into 14 2 times. Sometimes there's 10, so there's 4 left over. Okay? One of the things to keep in mind, y'all, is whatever this number is, you can never have anything inside that's bigger because that would be able to go into it. So these numbers inside, the exponents inside, always have to be smaller than your radical for it to be completely simplified. That's not what I wanted to do. Okay, simplify expression, rationalize the denominators. Okay, now this is the key here. I need 3 of the same thing to be able to bring one of them out. So 9 is 3 times 3. And then there's another 3. Well, I have 3 of them. So I can, if you want to circle them. That means I can bring one out. Boom. That's what it is. If you want to multiply it out, you can. But sometimes the numbers get so big, it's not easier to multiply it out. It's easier to break it up. Okay? Negative. Again, we've talked about that. Negative with the odd means you're going to have a negative in your answer. Okay? Again, cube root, 7. And then 49 is 7 times 7. I have 3 of them. So it's going to be negative 7. All right. Square root of 2 times the square root of 8. Okay. Again, bringing it up. 2 times 2 times 4. There's 2 of something. That's a perfect square. So the answer is 4. Could you have written the square root of 16? Absolutely, but the numbers are small, but I'm trying to get you into that habit of not always multiplying things out. Okay? Number 22. Okay? Same kind of numbers. Not so good. Anyway, but let's go. So you can do, again, 8 times 2 is a perfect square, so that's fine. I'm going to go with it because I don't really want to do that. So 8 is 4 times 2 times 2. And then how many x's do I have total? People that mess this up didn't realize that you can bring this all together under the same radical. So 2 times 2, x squared and x squared means I have 4 x's. So that is a perfect square, and that is a perfect square. That gives me 2 times 2, and this is a 2. 2 goes into 4 2 times. So that becomes 4x squared. Okay? All right, moving right along. Same one. I got, this time I have cube roots. The 5 is on the outside. It's going to stay on the outside. But I am not going to multiply 9 times 24. I need 3 of something before I can bring it out. So I'm not circling that. But 9 is 3 times 3. And 24 is 3 times 8. So I have 3 3's. And I have an 8, which is a perfect cube. And how many y's do I have? I have 3 of them. So that gives me 5. 1 3 comes out. The cube root of 8 is 2. And 3 goes into 3 one time. So this is going to give me 5 times 3 times 2, which is 30y. Okay? All right, moving along. 24. If my page will turn. Come on. Probably went twice there. All right. So after that, we have division. So that was the multiplication. Now we have some division. Every time you do division, y'all, you need to simplify first. Okay? You're making things way more complicated if you do not simplify the expression first. So 128 divided by 8 is 16. What's the square root of 16? 4. Okay, here I have cube roots, so I have the cube root of 81 divided by 3 is 27. If I have 5 x's on top and 2 on the bottom, that leaves me with 3 on the top, and I have 3 y's. So the cube root of 27 is 3. 3 goes into 3 one time, 3 goes into 3 one time, so I'm left with 3xy. Okay? All right, how about the fourth root? Okay, this one, 2 goes into 162 81 times. So I'm going to have 81 on top, and I have x to the 4th on top, and y to the 8th on the bottom. Okay, so I'm going to have a fraction here. The 4th root of 81 is 3. 4 goes into 4 one time. 4 goes into 8 2 times. It's on the bottom. It stays on the bottom. Okay? Now, this is an even and an even, and it came out as an odd. So this guy needs absolute values. All right? Bottom one doesn't because it's not an odd power coming out. Okay? Next one. Again, it's separate as we've seen in 25 and 26, but you can bring it together. But more importantly, when you bring that together, it becomes, you can simplify it as 4 over 3. Now, if you want to do this all over the radical, extend that radical and multiply it by 3 over 3, which several people did. But now I have 2 3's on the bottom, so one of them comes out. And what do I have left on top? Well, there's a perfect square. So that's going to come out, and it's going to become 2 square roots of 3 over 3. All right. Next. Okay, we had some of these at the front, which is why on the test I moved them all to the same area. We're doing square roots. That means I'm looking for 2 of the same thing underneath, or perfect square factors. In this case, it would be 9 and 3. And over here, it would be 4 and 3. So this is 10 times 3, and nothing else comes out. Leaves me with the square root of 3x minus 4 times 2. Oh, well, stop. put that back. Square roots of 3x. So if it can't come out, it just stays underneath. And remember, these two are what we refer to as blobs. They have to be exactly the same. And if they are, then you combine the numbers on the outside by whatever operation it tells you. This says 10 times 3 is 30 minus 8, and 30 minus 8 is 22. And my blob is the square root of 3x. All right, let's go with another one. All right, 20 is going to be 4 times 5. 45 is going to be 9 times 5, and that one's just 5. So this becomes 3 times 2 square roots of 5x plus 8 times 3 square roots of 5x. Please make sure that your radical extends over the whole radicand, and then 4 times the square root of 5x. So I have 6 plus 24, which is 30, and 30 minus 4 is 26 square roots of 5x. Okay, and let's keep going. So we got number 30. We're definitely halfway through. All right, so now we're talking about cube roots. So you really have to pay attention to that index. So this is cube roots, and the perfect cubes that come in are 27 times 2, which is going to give me 3. Actually, and that x comes out. 3 goes into 3 one time. So 3x times the cube root of 2. 16 is 8, which is the perfect cube, times 2. So that leaves me 2x cube roots of 2. Well, 3x minus 2x is just x. So that's x cube roots of 2. No, I don't want to do that. All right, let's go with... All right, we're multiplying. Okay, all those other ones we're adding. We had some dividing up there at the top. So adding, subtracting, and now multiplying. We are multiplying two binomials. So you want to remember our acronym of FOIL. The first terms, 3 times 4, give me 12. The outside terms, 3 times the square root of 2 is 3 square roots of 2. The inside is 4 times the square root of 2, which is 4 square roots of 2. And the last is the square root of 2 times the square root of 2, which is 2. That makes these two guys like terms. And 12 plus 2 is 14. And then these are like terms. They have the exact same radicand with the exact same index. So 3 plus 4 is 7 square roots of 2. All right, 32. This one, similar to what you did. Absolutely, you can do FOIL if you want to, but you will save yourself some time if you recognize these are conjugates of each other. So I'm squaring the first term. The square root of 5 squared is 5. Okay, don't do that to me, please. Go back. Always a minus because one's positive and one's negative. And then square the last term, and the square root of 11 squared is 11. So 5 minus 11 is negative 6. Okay. This time, they are not exactly the same. The first terms are the same, but the second ones are not. So that's going to give us, first term is 100. Outside term, 10 times the square root of 3. Inside terms, 10 square roots of 6. And that one didn't add right. And last term is, it's the square root of 6 times the square root of 3, which is that right there. If you want to multiply that out, you can, but look, there's going to be simplified. So this is going to end up with nothing that combines. So it's going to be 100 minus 10 square roots of 3 plus 10 square roots of 6 minus 3 square roots of 2. And I just barely squeezed that in. All right. 2 plus the square root of 5 over the square root of 5. Do not cancel those out. One is a term. They are not factors. You can only cancel out factors. Okay. So to get rid of the radical on the bottom, because I can't leave a radical on the bottom, I have to multiply by the square root of 5 over the square root of 5. Okay? That gives me on the top 2 square roots of 5 plus square root of 5 times square root of 5 is 5. And on the bottom, square root of 5 over square root of 5 times square root of 5 is 5. Again, do not cancel these out. This is a term. It is not a factor. And this cannot be simplified, so I could just move that whole thing over there, but I'm going to go ahead and put my answer in the blank because I know that's what the teacher wants, the answer in the blank. Okay? All right, let's look at this next one. It gets a little messy. Or a little long, however you want to think about it. Okay, so this one is when I have a adding or subtracting. Oh, I'm so sorry. Pause 1 second, please. All right, I'm back. So we are, it's different from number 34 because there is a plus or minus in the bottom. So we now have to multiply by the conjugate of the bottom, which is 1 minus the square root of 8 over 1 minus the square root of 8. Okay. It is important to write that bar. Some people aren't writing it. They just writing the numbers down. But please, it certainly makes more sense when you're doing that. Actually, I'm going to go down below here with this one. So this is going to become, hopefully I have room for that. Sorry for the, let me make that smaller. The crampedness of this problem. 1 minus the square root of 8 over 1 minus the square root of 8. Okay, so what does that give me on the bottom? The first number squared minus the second number squared. Always minus, y'all. 1 is plus, 1 is negative. Positive times negative is negative. Okay, first term is going to give me 3. The outside term is going to give me 3 square roots of 8. The inside term is going to give me minus the square root of 18. And the last term is going to give me, I am not multiplying that out, but it is 18, which is 9 times 2, and 8, which is 2 times 4. Don't you like how I squinched all that together? Well, that's a perfect square, and that's a perfect square, and that's a perfect square. So that's going to give me 3 times 2 times 2, which is 12. So that thing becomes 12. So that means this is going to be, I'm going to write it here so hopefully it won't interfere. On the bottom, of course, I have negative 7. And on the top, I have 3 minus 12, which is negative 9. And then I have this that I have to simplify. So 8 is 4 times 2. And so I'm actually going to go to a different color so maybe y'all can see that a little bit better, okay? So if this is 4 times 2, the square root of 4 is 2. So this becomes 6 square roots of 2, and that's, of course, negative. This is 9 times 2, which is minus 3 square roots of 2. And so, is it minus or plus? Or did I get 18? Oh, right here. It's minus. So that gives me minus 9 square roots of 2. Oh, goodness, my bad. One more interruption. 1 second, please. Okay, so that is what happens to me when I'm trying to do too many things at once. So I'm going to erase this guy. And at the bottom, I still have negative 7. The first term is 3 minus 12, which is negative 9. However, this 18 is from my inside terms, and that's positive times a positive. So this is plus, which means that this guy up here is plus. And therefore, negative 6 plus 3 is minus 3 square roots of 2. So, there's nothing that's in common to all of those. So our answer is going to be negative 9 minus 3 square roots of 2 over negative 7. And just so you don't get confused with the other stuff of that problem, that is the answer. Okay, almost done here. We have some rational exponents, okay? When you raise a power to a power, you multiply those exponents. So 1/4 times 4 over 1 is 1. So the answer is just x. All right, on the next one, there's no plus or minus inside like you have on some of these problems up here. So that means that, hold on one second so we can see the problems. You have to take this to both factors inside of there. So -8 to the 1/3 power, remember that's like the cube root of -8, which is -2. And then 9 times 1/3 is 3, so it's going to be y to the third. Okay. This one, I would probably say that if you took 9xy squared, the square root of that is raising it to the 1/2. And if you raise that whole thing to the 4th, then you're multiplying these two, which means it's the same thing as 9xy squared squared. So what are you going to do? You're going to distribute the square to every factor. So that's going to give you 81x squared y to the 4th. Okay. And what do we have? All right. Again, whenever you have these things, if you have multiple factors inside, make sure that you can factor them, or not factor them. See if you can simplify them first. Okay, I cannot simplify x and y, so I'm just going to do what I've been doing, and that's distributing it. There's no plus or minus inside, so I'm multiplying 1/6 times -18, and that is x to the -3, and then y to the -6. And as I mentioned to you at the beginning, okay, you will see some of these negative exponents at the beginning. If you have a negative exponent, that's when it goes in the bottom and you make it positive, because you're never going to leave an answer with a negative exponent on it. Okay? And this one. All right, this is one where I have an x on the top and the bottom, and I can actually simplify that. So when we divide, we subtract the exponents. So 4 minus a -1 is 4 plus 1, and 4 plus 1 is 5, and 5 to the -1/5. So I'm going to raise a power to a power, which means I'm multiplying those exponents. And when I multiply them, I get x to the -1. Cannot leave it as x to the -1. That becomes 1 over x. Okay? And this one, I have an x and a y in the top and the bottom. I cannot combine those. One is an x and one is a y. Over here with this problem, they were both x's. So I have no choice but to just distribute that 9. And so 1/3 times -9 is x to the -3. And 2/3 times -9 is y to the -6. And again, the negative exponent, you make it positive and put it in the opposite place between the numerator and the denominator. So this is going to give us y to the 6th over x to the 3rd. Okay, we are on the home stretch because we're into equations, okay? There are 6 equations on here. I will tell you that there are 3 of them on your test. Actually, there's 4. 3 of them are required. The 4th one is a bonus. So if you know how to do all these equations, you'll be able to do a bonus problem on the test. Okay, so first off, you isolate. When you have a radical in there, you're isolating that radical, and then you're going to raise it to the power suggested by the index. My index is a 2, so I'm going to raise both sides to the 2nd power. Because if I have a square root and I square it, then they cancel each other out. Okay, so I'm going to have x minus 3 equals, and I have to square this. This is becomes our PST, which means I square the first one, multiply them together times 2, and then square the last one. Okay, it's a quadratic equation. I'm going to set everything equal to 0. So I don't have an x squared moving, but if I bring this x over here, I'm subtracting an x. And if I bring that 3 over here, I'm adding 3. So I end up with that quadratic equation. I'm going to factor it, x minus 7 and x minus 4. And when I set each of those factors equal to 0, that's x minus 7 equals 0 and x minus 4 equals 0. So I'm going to check. If I put 7 in here, 7 minus 3 is 4. The square root of 4 is 7 minus 5. Is that true? That is true. So x equals 7. Let's put 4 in here. 4 minus 3 is 1. The square root of 1 is 4 minus 5 is negative 1. It's not. So that one doesn't work. So it's just x equals 7. Okay? Let's look at the next one. Okay, we've talked about it. You've got to isolate the part that's involved with the radical or the rational exponent. So I do need to divide both sides by 2. And I will have x minus 1 to the 3/4. Don't do that to me. All right, we all saw that, so let's just write x minus 1 to the 3/4 equals 16 divided by 2 is 8. Now, when you have a rational exponent like this, we are raising both sides to the reciprocal of that, which is 4/3. So I'm raising this to the 4/3. That becomes 1 because when you multiply reciprocals by each other, they become 1. So x minus 1 equals 8 to the 4/3. Punch that in your calculator. I'm not testing that right here. Okay? So put in your calculator 8 caret symbol, put parentheses around that, 4 divided by 3, which is the cube root of 8, which is 2, and 2 to the 4th power is 16. So you're going to get x minus 1 equals 16. Okay? Now, we have talked about when any part of that is got an even number, okay, then you need to put absolute value around it. And we solve that by creating two cases, kind of like that upside down V. So x minus 1 equals 16, and x minus 1 equals negative 16. So if I add 1 to that, I get x equals 17. I'm going to go put that up here. And let's go check that out. 17 minus 1 is 16. And 16 raised to the 3/4 is the 4th root of 16, which is 2, to the 3rd power, which is 8. 8 times 2 is 16, so we're good. Now this one gives us negative 15. And when I put negative 15 in here, I get negative 16. And you can't take the 4th root of negative 16, so that one actually ends up not working. Okay? All right, moving on. We have another radical, and this is to the 5th power. So again, I have to get that radical all by itself. So first I'm going to add 1, so that's going to give me 2 times the 5th root of 5x plus 2 equals add 1, 3 plus 1 is 4. Then I have to divide by 2. So that is the 5th root of 5x plus 2 equals 4 divided by 2 is 2. Now, to get rid of that 5th root, I'm going to raise both sides to the 5th power. So on the left, I have 5x plus 2. And on the right, I have 2 to the 5th, and 2 to the 5th is 32. Subtract 2, 5x equals 30. Divide by 5, and x equals 6. And I'm going to check. 5 times 6 is 30. 30 plus 2 is 32. The 5th root of 32 is 2. 2 times 2 is 4. 4 minus 1 is 3, so it checks. I would expect you to just put it in your calculator in one fell swoop. And again, tomorrow during class would be the time to ask me, or before school, come ask me if you don't know how to use your calculator to check these problems. All right. Another rational exponent. Again, we have to isolate it, so I'm going to subtract 3. So that's going to give me 6x minus 5 to the 1/3 power equals negative 5. All right, and I have a rational exponent. Then I'm going to raise both sides by its reciprocal, which is 3 over 1. So that's going to give me 6x minus 5. Thank you. 6x minus 5 equals negative 125. So I'm going to add 5 to both sides. 6x equals negative 120. Divide by 6, and x equals negative 20. Okay, check it. 6 times negative 20, negative 120 minus 5 is negative 125. The cube root of negative 125 is negative 5 plus 3, and that's negative 2. So we are good to go. Come on. Poke, poke, poke. All right, 2 more. All right, so we have another radical, not by itself this time, so I have to add 1, and that gives me square root of x plus 3 equals x plus 1. All right, my index is a 2, so I'm going to square both sides. The radical and the square will cancel out, leaving me with x plus 3 equals x squared plus 2x plus 1. That's our PST. We've talked many times about factoring. Quadratic, I got to bring it to one side. Don't have an x squared on that side. Subtract x. 2x minus x is x. Subtract 3. 1 minus 3 is negative 2. And this factors. And I'll tell y'all, as I've told you in class, I'm not trying to trick you on this. If it doesn't factor, check your math. Okay, it will. These problems, if I give you one, you're going to be able to solve that quadratic. Okay, so x plus 2, x minus 1, and as we've done, x plus 2 equals 0, x minus 1 equals 0. So that tells me x equals negative 2 or positive 1. So if I put negative 2 in here, negative 2 plus 3 is 1. The square root of 1 minus 1, is that equal to negative 2? It's not, so this one's not going to work. If that tells me x equals 1, 1 plus 3 is 4. The square root of 4 is 2. 2 minus 1 is 1, and that's what x is. So this is x equals 1. All right, so each of these, if we only had 1, oh, well, we'll see what happens. Maybe we'll get something different this time. All right. Oh, look at this one. So this one here, y'all, has 2 radicals, and we talked about that. Get the one that looks a little bigger all by itself. So I'm going to take this to the other side. So that gives me the square root of 5x plus 1 equals 1 plus 2 square roots of x. I'm going to raise this up a little bit. Wait, so I have more room. Okay, and now I'm going to square both sides. And so you all know on the left side, 5x plus 1. And now on the right, PST, we square the first term. We multiply them together times 2, so that's 4 square roots of x. And then I square that last term. And when I square that, I got to square the 2 and square the radical. So that's what I get. Now I still have a radical equation, so I'm trying to get this guy by itself. So when I subtract the 1's, they go away. When I subtract 4x, I'm left with x equals 4 square roots of x. Now, I'm not going to divide by 4 because it's going to leave me a fraction, but I am going to square to get rid of the radical again. And that gives me x squared equals 16x. You got to square the 4 and square the radical. Quadratic, bring it to one side. So x squared minus 16x equals 0. Now, if I didn't have an x there, then I'd take the square root of both sides and say x equals plus or minus 4. However, I do have an x in it, so that's a common factor. So I take that out, and x minus 16. So this tells me x equals 0, or x minus 16 equals 0. So if I put in 0 up here, that goes away. So the square root of 1 minus 2, no, that's 0. LOL. The square root of 1 minus 0, does that equal 1? Well, it does. So x equals 0. Now let's put in 16. 16 times 5 is 80 plus 1. So the square root of 81 is 9. And 9 minus the square root of 16 is 4. 2 times 4 is 8. 9 minus 8 equals 1. So this time we had 2 answers. And that is your study guide for Unit 3C. I hope that it helped prepare you for your test. If you have any questions, please email me or come see me in the morning. Thank you very much.